Okay, now let's put all of this information about the basics of the blockchain aside and look at the problem in our area of interest, which is bringing the internet connectivity to those places that are still unconnected, and see how blockchain technology could be a help to it. Digital era brought the ability of using several applications offered on the internet, which can improve users' lifestyle and livelihood. Services such as healthcare services, educational services like distance learning, like right now that you are listening to me after it's being recorded. Financial services such as services in security markets, e-governance services, precision farming, supply chain, where the customer would be able to see how the product was produced step by step and how it was delivered to the market. Communication services, transportation services, like when you book your train ticket or your airplane ticket to your destination. And in a disaster relief scenario also, this kind of services, or in any other use cases, these digital services are being used. The life of people in developed country is highly dependent on the internet because it's been a while since they have access to the internet, and gradually several types of services have been made on top of the internet and offered through the internet. The scenario in the developing countries is different, especially in the rural areas. Most of the people in the rural areas don't have access to the internet. Either they don't have the internet coverage, or they don't have enough knowledge about it as the digital literacy, or they suffer from a bad financial condition. Without the internet, they miss the chance of improving their lifestyle and livelihood. They could use precision farming, for example, where sensors and collected data from their lands help them in their farming processes. Or they could use disaster relief services in the emergency scenarios, and so on. So, to cover those areas, we normally expect the mobile network operators, or MNOs, to extend their network infrastructures and simply solve the problem. To act like that, MNOs should constantly deploy new infrastructures and keep maintaining them. And it will be very costly. Since those areas are low populated, MNOs don't have enough incentive to invest in deploying new infrastructures or update their old infrastructures in that area. Then, how do we solve this problem? As we proposed in our papers, and you might have read it by now, we believe sharing networking infrastructures could be the solution to this digital divide problem, and can be a way to connect the unconnected people in the rural areas. Sharing the infrastructures between different entities would also help to bring 5G connections, as its coverage capability is less in compare with the fourth generation because of its lower wavelength and the higher frequency in use. So we need different stakeholders such as local community networks or LCNs, government councils, non-governmental organizations or NGOs, enterprises, utility companies, etc., to work together to solve this problem. In the mentioned stakeholders, the local community networks can act as a bridge or a golden key to bring connection to those areas. University campuses, factory networks, government-owned networks, etc., could have this local community network type, and share the infrastructure with uh, public MNOs. Hopefully, after accessing the internet, people in the rural areas also can use internet-based services such as precision agriculture or distance learning to elevate their livelihood and quality of their life. But sharing infrastructures need agreements and mutual understanding between business parties, right? This makes the process very complicated and time consuming. This um, having the agreements and reaching to a stage of mutual understanding. And this really could be a great barrier in the process. Any agreement also needs trust, and you won't go and do business with someone you don't trust, right? So this brings the third parties like governmental bodies to recognize and confirm the agreements between the business parties in any event. Business agreements also needs payments and insurances. So this will bring the banks and insurance companies to the picture. And this need of having third parties helping us in doing the business makes it more complicated. So here is where the blockchain comes to help. The blockchain brings automation to the agreements by using smart contracts. It builds trust and it identifies the business parties in a way that none of them need to know or spend so much time on knowing each other before the agreement. It offers security and data is encrypted in the database and prevents unauthorized access to the database for a better privacy, as I mentioned earlier. It also removes the need of third parties such as banks and insurance companies. All of these attributes are needed to kind of shorten the time and the complexity of bringing agreement between the different parties for sharing their networking infrastructures. But let's see how it does all of that. Based on our papers, in the infrastructure sharing scenario, we need a framework to create agreements, manage necessary payments, penalize malicious actors, automate the processes, and preserve the data privacy, all at the time of sharing the data, the networking infrastructures. By utilizing blockchain, each participating entity, such as any MNO or LCN or any subscriber, will have a pair of key, a private key and a public key, as I defined it earlier, as I mentioned it, to handle their identity and payments, a digital wallet to hold their digital assets, and a decentralized application, which I will get back to it later on. Let's see how the handover process is done using this solution. When a user moves towards the border of its home service provider coverage zone, and the user equipment or the UE figures out this movement, for example, by measuring the received signal, received power, would search for the neighbor network to latch to it before its current connection would be disconnected or would be cut from its home service provider for a kind of smooth transition. A decentralized application, which is called the Slice Connect application in the paper, will create a list of available networks and tries to check if they are capable of delivering the required service. And further on, it drops those networks incapable of delivering that specific service type. In case if you wonder what is a decentralized application, a decentralized application or a DApp is an application hosted by all nodes holding the ledger instead of one centralized server. It will be the same as the normal applications, but the server will be different from the typical situation. So this app, a decentralized app called Slice Connect, installed on the user's equipment, also helps us to monitor the quality of the received services from hosting MNO, because we are expecting the service provider delivers what it is expected from it, right? So and the payment should be deducted from the service receiver before actually he receives the service. So we need to get sure that a specific quality of the service is delivered to the service receiver before we release the money to the service provider. Now, when the candidates are shortlisted, the final network to receive the handover request will be selected by a bidding process. Um, in other words, a process in which the cheaper service provider will be selected. After sending the handover request, the visited network will create a new block on the blockchain or on the ledger to ask the subscriber's home network for an authentication. The home network then would send the acknowledgement by creating a new block on the same blockchain. Now there might be two scenarios for prepaid and postpaid subscribers. So simply, in the prepaid scenario, if the subscriber doesn't have enough balance, he won't get the authentication and won't receive the service, needing to recharge before requesting for the service. And in the postpaid, subscriber will receive the service and pays for it later on at the time of clearing the paying the bill to his home network provider. So after latching to the network, whenever the user requests a new service, one smart contract will be initiated between the visited network and the home network. So please pay attention here that the smart contract will be initiated between or created between the visited network and the home network, not the visited network and the subscriber, because the subscriber is going to pay to the home network, to its home network, and the home network is going to pay to visited network, right? But later on, we can expand it to a situation that the user can kind of charge for himself and pays for its requested services directly. So the charges will be sent to the home network, as I mentioned. It will be deducted from its digital wallet before the service starts and will be paid to the visited network after the service delivers to the subscriber. This is the way that the smart contract works. Remember Alice and Bob? Bob needs to deliver the file, then receive the digital assets, but Alice needs to pay the money before receiving the whatever she requested for, like in that case, the file, right? So in between, the smart contract will get the money from one party, making sure that she will pay, and will wait for the other party to meet the terms of the agreement, and then will be paying to him. Okay, so the quality of the service will be monitored by that specific digital decentralized application installed on the user's equipment. As I mentioned earlier, for each and every request, a new smart contract will be initiated to separately handle the payments. So when the visited network signs the agreement, the blockchain module residing in the network management system, NMS, sends the confirmation signal to the network service orchestration, NSO, and then it will set the service as per the request to be delivered to the subscriber. As you can see in the figure number 3 of the paper, the NSO at the LCM side will send the slice to the NSO at the MNO side, and then the NSO, as I mentioned earlier, will wait for the blockchain module to confirm the request. It will check whether the smart contract has been done, the home network provider confirms, authorizes the users and everything. So right after that, it will orchestrate the other segments or modules in a way that will fit the request of the subscriber. So to give you an idea what is inside the smart contract, in this case, as you can see in figure 4, when a new handover request is received, a new block will be created by the visited network, and authentication is requested from the home service provider. And we know both the home service provider and the visited network provider are participating in the same blockchain. After that, if the permission was granted according to the requested service, new smart contract will be initiated, and NSO will be receiving the signal to manage the appropriate modules as per the requested service. And if new service request was received afterward, only one new smart contract will be created, and not the authentication part to be repeated again, because the user is already connected to the network, to the visited network. Okay, this blockchain-based system is capable of doing much more than just a handover process. And this fact leads us to the second capability mentioned in the paper, which is to securely share the location of the subscriber with a third party as per the user's request. We know having data security and data privacy are as important as having access to the services offered on the internet, right? Currently, when you install an application on your cell phone, you are required to grant various types of permissions in some of the cases to it. So after installation, if you decide to prevent it from having that kind of permissions, you will only have one option, which is not to using it at all, or simply uninstall it, right? To solve this problem, MNOs may introduce specific applications to their users which are approved by them, and these applications may need users' locations or other private data to provide them with their specific services. For example, services that relies on the location of the user to provide specific information about that place. If you can think of an application which provides some data in historical places. This solution lets MNOs securely share their users' locations with third-party applications when users request them to do so. In this scenario, all actors, the users, the MNO, and the third party, will have their own decentralized application connected to each other, connected to the same blockchain. This decentralized application will help to handle the data transfer procedure and to keep the privacy of the user. Now let's see how this location sharing process works. First, user installs an application approved by the MNO, which is capable of working with this system, this blockchain-based system. Then user opens the application, which is, in this case, needs the user's location to offer its service. The application will request send a request to the Slice Connect decentralized application. We talked about it before, to start the procedure for revealing user's location. Next, this Slice Connect decentralized application will save a block on the blockchain containing a request to the connected MNO with a specific set of information such as that MNO's ID, user's ID, the third-party application's ID, and the requested data, which needs to be sent to that third-party server. This request automatically initiates a smart contract between the MNO and the third party, which is hosting the application just ran by the user. The smart contract will check the balance in third party's digital wallet, and if approved, if the balance was enough for receiving that service, that information from the MNO, if approved, then it will deduct that amount from it and lets the decentralized application on MNO side to know that it's time for sharing that data which is requested with the third party server. So there is, as I mentioned, there is another decentralized application at the third party side. The MNO will send this data to that decentralized application. So the MNO will encrypt the data and send it to that side of the business. I mean the destination of this data, which is a third-party decentralized application. When the decentralized application at a third-party server receives the data, will send and acknowledge back to the smart contract for releasing the asset which has been blocked in third party's digital wallet. Simultaneously, the location data which just received from the MNO will be used to prepare the services for the user. As you can see, this procedure helps us to share kind of sensitive kind of data with other parties like the locations. The whole process is started and controlled by the user, so no other application will be interfering in between, and all the data will be secured over the internet. To conclude this session, I would say you can use blockchain technology almost in any scenario that may use extra security and privacy. Okay, so I hope you learned from this session, and please let me know if you have any doubts and questions. Thank you so much.